So let's look at B part 2. B part 2, you're asked to find the exact volume of the solid generated when the shaded region is rotated 180 degrees about the y-axis. In other words, 180 degrees about y-axis will mean that you just need to take one side for 360, right? 180 degrees for across two sides will just be one-sided 360. So essentially, we just need to consider one side. That's all we need. Let's see how we can do this proficiently. Let me just copy and paste the equation now on a blank canvas. So let's look at this curve here. We have already established that the top curve here would have equation of plus 2 plus root x root 4 minus x squared over 4, and the one below would be taking the negative expression. So we don't really need the negative one because we just need the positive one. So let's just look at the positive side. When we are rotating this area about the y-axis, 180 degrees, we're actually rotating one side with 360. So that is pretty okay. Now the first thing is to be able to understand that there's a part of a cylinder here. This rectangle, when it's rotated about the y-axis, there's a rectangle below. Whereas there's a small dome on top, like there's a small sort of like a hemispherical shape, right, on top that we need to take note of. So what I'm saying is you must be able to visualize that we need to find this because now we are supposed to solve it exactly. We need to solve for the point there exactly as well. So this is when x equals to 3. Okay, so I'm just going to key this in to find this. So when x equals to 3, we know that y is equals to 2 plus 4 minus 3 squared over 4, and after which I will get 4 minus 9 over 4, which is actually 7 over 4. Okay, 7 over 4. So 2 plus 7 over 4. So this case here, what I'll get is actually just 2 plus half root 7, sorry. The root 4 I'm just bringing. So this is actually 2 Alright, great. So let's see how we can do this properly. So you must be able to tell there is the cylinder below and the top one, right? So this when x is 0 is pretty okay. That will be a 4. This will be 0, 4, right? This point here when x is 0. So I'm not going to do that because I think that's pretty okay. I'm gonna try and model this thing up for you so that you could visualize it. So you can see that I just plotted this into SketchUp. So what I'm going to do is actually just going to model this side here. What I meant about when you rotate about 180 degrees. So let me just do it properly. So this part here, as I have already like put this graph, as in just plot this out, model this out. If you were to move it like 180 along the y-axis, all right, so it will look something like that. 180. So you just need 180 to give a full revolution, right? Because this is like moving, like you see. So if I were to move 180, it's actually 360 of a side. All right, so that's how it looks like. Now, what I need you to understand is essentially there's a small cylinder below here, and there's a top curve here, curvature here. So actually, essentially, what you need to do is actually just to integrate from this side to this side. This side to this side, you could just apply the cylinder formula, whereas from the 2 plus root 7 to the 4 here, you just integrate under this curve here and rotate by the y-axis. All right, so that's what we're going to do. If you're able to you need to be able to visualize this. I know some students may struggle, but just keep practicing. Okay, so what we're going to do is essentially just going to find the area of the what do you call it, the the trapeze, the cylinder plus the area on top. So just going to proceed to do that. Okay, let's see how we can do that properly. First thing first is let's look at this equation here. So if I were to just I think the cylinder is okay. Cylinder, this equation looks difficult, but we're gonna look at the first part, which we have already found. I'm not sure whether we need to use it doesn't seem like it's related, so I'm just gonna try and see whether I could integrate this. Okay, we got 2 roots and so on. So the volume required, the required volume would be the integral pi from 2 plus half root 7 to 4. Then you have x squared dy. Alright, so that's pretty good. So if you look at x squared dy, right, we see that we could, right? We could integrate x squared. X squared is pretty okay. After which we just add the volume of cylinder. So this would be the shape of the dome on top. Add the dome on top like that. Then this over here, the cylinder, what we have is essentially a cylinder below, and this would be a radius of 3 and a height of 2 plus half root 7, right? So that is how we, oh no, this is not, this is 2, so this is actually half root 7 as a height, because you take 2 from 2 to here will be just half root 7 increment. So this part here will be root 7 2, and the radius is just 3. Alright, so that's how you be able to visualize this part here. So I'm just going to do this part carefully. So we have pi r square and times the height, which is root 7 over 2. Great. Then what I'm going to do is actually just make x a subject. So x squared over 16 plus y over square 4 equals to 1. So I know that this is x squared equals to 1 minus y squared over 4 times 16. So this is what I'll get. Is that it? Sorry, I may have written the wrong. So this is y minus 2. Sorry, this is y minus 2 square over 4, and this is, yeah. Great. So once you get that ready, what you're going to do is actually just going to put it into the calculator. I mean, not calculator, sorry, just put in the equation here. There's 2 plus half root 7, 4, x squared will be 16, 1 minus 1 minus y minus 2 square. So this is y minus 2 square over 4. It's okay. dy. Alright, so that's how we do this part here, dy. Then after which we are going to just integrate it, because this is integratable. This is just this is linear in it, so we could integrate it properly. So yeah, let's see how we can do this. So this is 9 over 2 root 7, the volume of cylinder, 2 root 7 pi. Okay, and 16, bring it out, 16 pi. After which we just have y minus 2 cubed over 12, 4, 2 plus root 7. Okay, so that's what you do. And since you want the exact root, so you just have to, I mean exact volume, so you just have to slowly do it. And you have 4 minus 2 will be 2, which is 8 over 12 for the first one. After which we have got 2 plus half 7 minus 7 cubed over 12. Just be mindful of your manipulation. Don't be too quick, be very careful about it. So this is 10 over 3 plus, after which would just be 2 plus half root 7. This would be, I'm just going to be quick, 1 over 8 root 7 times root 7 times root 7. So half the power 3 is 1 over 8. So this would just be 7 over 8 root 7. Okay, so there you go. This part here will just be minus 7 over 8 root 7 divided by 12. Okay, so this case here, what we get is very quickly, sorry, this is minus. Oh my goodness, so this is minus, this is plus, and this is 9 over 2 root 7 pi. Yeah, so I'm just going to slowly do this part here. It's very, very annoying, I know, but we just have to slowly, not to be very delicate about it. Minus, yeah. Alright, this is minus, sorry. Alright, great. So once we're done, we would actually get this as 16 pi 10 over 3 minus 2, which is actually 4/3 minus of 1 over 2 plus 7 over 8 times 12, which is actually okay. And there you go. I'm gonna try negative 7 over 3. Negative 7 over 3 root 7 pi, and we have 4 over 3 times 16, which is actually just 64. Right, so that's your answer here. Cube units. Okay, any question or comments, please do let us know. Keep practicing, and I'll see you in the next question.